Line 22, 7B126, Supernova Neutrino Core Collapse Gravitational Wave Wow Seti. And I better double check and see if there's a formula, I think. No, no, there's no formula on this one, it's just thoughts. Okay. Okay, so we have line 22, 7B125, helium, hydrogen ions, electrons, neutrinos, formula Wow Seti was the previous video. We're going to talk about the core collapse of a superneutrinos, create a gravitational wave pull on Earth's crust theories, line 22, wow data. Okay, so supernova neutrino, Google next video, which is this one. We're going to Google it in this one. Sorry. So quote PDF file results on a blog. Supernova neutrino detection from Kate Scholberg from May 2012. A core collapse supernova will produce an enormous burst of neutrinos of all flavors in the few tens of MeV range. Measurement of the flavor, time, and energy structure of a nearby core collapse neutrino burst will yield answers to many physics and astrophysics questions. The neutrinos left over from past cosmic supernovae are also observable, and their detection will improve knowledge of core collapse rates and average neutrino emission. This review describes experimental techniques for detection of core collapse neutrinos as well as the sensitivities of current and future detectors. Okay, and that's the Nuclear and Particle Science, October 2012. Subjects is instrumentation and methods for astrophysics, high energy physics, experiment, phenomenology, and nuclear experiment. And it's on the website arxib.org, okay? And that's, you can email Kate if you want to talk to her. You would go to that site to talk to her there. So the keyword superneutrinos plus gravitational waves, quote PDF results on blog, core collapse, supernovae, neutrinos, and gravitational waves from all these different scientists. December 2012. Core collapse supernovae are among the most energetic cosmic catalysms. They are prodigious emitters of neutrinos and quite likely strong galactic sources of gravitational waves. Observations of both neutrinos and gravitational waves from the next galactic or near galactic core collapse supernova will yield a wealth of information on the explosion mechanism, but also on the structure and angular momentum of the progenitor star and on aspects of fundamental physics such as the equation of state or of nuclear matter at high densities and low entropies. In this contribution to the proceedings of the Neutrino 2012 conference, we summarized recent progress made in the theoretical understanding and modeling of core collapse supernovae. In this, our emphasis is on multidimensional processes involved in the explosion mechanisms such as neutrino-driven convection and the standing accretion shock instability. As an example of how supernovae neutrinos can be used to probe fundamental physics, we discussed how the rise time of the electron antineutrino flux observed in detectors can be used to probe the neutrino mass hierarchy. Finally, we lay out aspects of the neutrino and gravitational wave signature of core collapse supernovae and discuss the power of combined analysis of neutrino and gravitational wave data from the next galactic core collapse supernova. And that's from Japan and Christian D. Ott. You can email them at arxiv.org is where you can find the link. December 9th, my thoughts. So the core collapse supernovae neutrinos create the gravitational wave pull to other mass and massive particles in the Higgs electric field, thus forming the planet after the hydrogen ions comet with water and helium collide to create a big bang of colliding heat. Then the ultra-cold rubidium atoms cool and form the planet's crust. They make different types of crystals because of the organisms that are living and breathing inside each particle of dark matter. The dark matter is porous, but this still doesn't explain how the organisms came to be inside the dark matter. Data continues in the next video. Thanks for watching.